At midnight, Arco hears scratching beside the food basket. The sound is tiny, but every sleeper in the shelter knows what it means. Something has found the grain. Arco lifts his head and watches a mouse squeeze through a gap in the wall. It freezes for half a second. Then another shape moves in the darkness. Low body. Silent pause. Eyes locked forward. A wildcat has smelled the same visitor. The mouse runs. The cat explodes after it. For a few seconds, the shelter becomes the oldest chase scene on Earth. And here is the strange part. Nobody taught either animal the rules. The mouse does not wait to ask whether the cat is friendly. The cat does not need a lesson explaining that a mouse can be prey. One sees danger, the other sees opportunity. Humans have watched versions of this chase for thousands of years, so it is easy to imagine that cats and mice have always been personal enemies. But nature did not begin with a cartoon rivalry. There was no first mouse that insulted a cat. There was no ancient argument that every generation remembered, and science cannot identify one literal first cat and mouse fight in the fossil record. The real story is stranger because the rivalry was built slowly by survival. Predators that caught small animals left more descendants. Small animals that detected predators sooner also left more descendants. Generation after generation, pursuit improved on one side and escape improved on the other. Then humans changed the battlefield. Permanent settlements created food stores that mice could exploit. Those mice attracted wildcats toward people. And an ancient predator-prey relationship moved directly into the human home. To understand the rivalry, we have to go back before either animal lived beside us. Small rodents had been surviving predators long before the first farming village existed. Wildcats had also been hunting small vertebrates long before humans stored grain. So the basic conflict is older than domestication. It is not really cat versus mouse. It is predator versus prey. A small felid survives by detecting movement, sound, scent, and vulnerability. A small rodent survives by detecting exactly the opposite, signs of an approaching hunter. That creates two completely different ways of reading the same landscape. To a cat, rustling grass may announce dinner. To a mouse, the same rustle may announce death. Cats are built for short, explosive attacks rather than marathon pursuit. Their bodies stay low while stalking because surprise saves energy. Their eyes and ears constantly track tiny changes around them. Their whiskers help them judge close spaces when the chase becomes tight. Mice solve the problem from the other direction. They use narrow gaps, cover, quick turns, smell, and constant risk assessment. Open ground is expensive for a mouse because every extra second increases exposure. A hole in a wall is not just a hole. To a mouse, it can be a survival door. A patient cat can wait beside that door because prey often has to emerge eventually. This is why the chase can look almost intelligent on both sides. It is intelligent behavior, but it is also shaped by millions of repeated survival decisions. Neither side needs hatred for the system to work. The cat benefits from calories. The mouse benefits from not becoming those calories. That simple imbalance creates extraordinary pressure. Every failed hunt costs a predator time and energy. Every failed escape can end a prey animal's life. That is the engine that keeps the rivalry moving. Then humans began doing something that changed the ecology around them. Some groups stopped moving constantly and built larger, longer-lasting settlements. Around 14,500 years ago, in parts of the Levant, house mice began exploiting some large, sedentary human settlements. Humans had accidentally created a new mouse paradise. Food scraps appeared in predictable places. Shelters reduced exposure to weather. Dense human activity changed which predators and competitors could enter safely. And later, agriculture made the opportunity even larger. Grain could now accumulate in the same place for long periods. A mouse no longer had to search a huge landscape for scattered seeds. It could live beside a concentrated food bank built by another species. From the mouse's perspective, this was one of the greatest real estate opportunities in history. But every opportunity creates a new problem. More mice meant more smells. More movement meant more sound. More predictable feeding routes meant predators could learn where to wait. The village was rich, but it was not invisible. Imagine Arco's settlement after sunset. People sleep around dying fires. Grain sits in baskets and pits. A mouse slips from cover and begins feeding. It has entered the human niche, but outside the shelter a Near Eastern wildcat is hunting. It does not care about agriculture. It cares that prey has become unusually concentrated. One successful hunt encourages the cat to return. One successful escape encourages surviving mice to remain cautious. Soon the village becomes a meeting point for three species. Humans supply the food landscape. Mice and cats turn it into an evolutionary triangle. Wildcats did not originally approach villages because they wanted to become pets. The most likely early attraction was ecological opportunity. Human settlements supported dense populations of rodents. For a small carnivore, that could be worth tolerating human noise and smell. Bolder wildcats could hunt closer to people than more fearful individuals. If humans tolerated those cats, both species gained something without signing any agreement. The humans lost fewer rodents to their stores. The cats gained a dependable hunting ground. This kind of relationship is called a commensal pathway to domestication. It may have begun before humans deliberately controlled cats in the modern sense. Genetic evidence traces domestic cats mainly to Near Eastern and North African wildcat ancestors. Archaeology also shows early human-cat associations in the Neolithic Near East and Cyprus. On Cyprus, people transported cats to an island where house mice had also arrived with humans. That detail matters. Cats were now moving with the human ecological package. Food storage attracted mice. Mice attracted cats. Humans increasingly tolerated the cats that helped reduce the problem. No one needed to invent the cat and mouse chase. Humans simply concentrated both sides in the same place. The old predator-prey relationship suddenly became visible every night around our homes. That is probably why the rivalry feels uniquely human, even though it is not. We became the landlord of the battlefield. The mouse learned to exploit our buildings. The cat learned to exploit the animals, exploiting our buildings. And people learned that one predator could protect food from another visitor. Over thousands of years, cats spread with human movement and trade. House mice also spread through human transport and settlements. Where the two species met, the chase followed, not because history repeated itself, but because the same ecological problem repeated itself. We cannot replay the first village chase, so this next scene is a scientific reconstruction, not a recorded event. Picture a farming settlement in the ancient Near East after dark. Arco's family has spent weeks gathering and protecting grain. A mouse colony has discovered the store. At first the damage seems small. A few seeds disappear. Then droppings appear beside the baskets. More mice begin feeding at night. Arco blocks one hole with stone. The mice open another route through softer material. Humans are now fighting a problem they accidentally created by storing food. One evening, a wildcat begins hunting near the settlement edge. People notice it, but keep their distance. The cat notices the people and does the same. Then the mouse appears. The cat's attention changes instantly. Its body drops low. Its steps become slower. The mouse pauses, perhaps detecting movement or predator scent. 1 second becomes a negotiation between two nervous systems. Then the mouse bolts. The wildcat launches. The mouse reaches a narrow crack before the cat's paws close around it. Tonight, the prey wins. Tomorrow, the cat may wait closer to that escape route. The mouse may choose a different path. Neither animal needs to understand evolution. Each only needs to survive the next encounter. But across thousands of encounters, survival changes which traits remain common. That is how a local chase becomes a generational pattern. This is where the story becomes especially strange. A young mouse does not need a family history lesson about cats before it can respond to predator cues. Rodents have neural systems that can produce defensive behaviour to some predator odours without prior training. Researchers call this an innate response. Innate does not mean perfectly automatic in every situation. Experience still matters. Context still matters. Different predator cues can activate different sensory pathways, but some threat detection machinery is present before a mouse personally survives a predator attack. That does not mean the mouse inherited a memory of one ancient cat. Memories are not being copied like a storybook from parent to child. What natural selection can preserve are biological tendencies that improve survival. Imagine 10 generations of mice living around dangerous predators. Some individuals ignore predator cues too easily. Others become alert more quickly. If the quicker response helps more of them reproduce, genes influencing that response can become more common. After many generations, the population can look as though it remembers the enemy. But the information is stored in evolved biology, not a conscious ancestral memory. A mouse can also learn during its own lifetime. A harmless smell paired with danger can later become frightening. So the brain combines two systems. One system arrives with inherited biases. Another updates those biases using experience. That combination is powerful. Too little fear is dangerous. Too much fear wastes feeding opportunities. The winning strategy is not panic at everything. It is detecting meaningful risk quickly enough to survive. That is why every new generation can restart the ancient game without being taught the original rules. Evolution wrote part of the warning system before birth. Now turn the problem around. Why does a kitten become fascinated by tiny moving objects? Again, there is no inherited personal hatred of mice. Cats are specialized predators. Movement can activate stalking, chasing, pouncing, and grabbing behavior. A leaf can trigger part of the sequence. A toy mouse can trigger part of the sequence. A real mouse can trigger the entire problem at once. Young cats also improve hunting through play and experience. Kittens chase siblings, objects, insects, shadows, and anything that behaves like escaping prey. Play is not identical to hunting, but it trains coordination. Timing improves, balance improves, paw control improves, attention learns what movement matters. Mother cats can also influence hunting development by exposing kittens to prey. So cat behavior, like mouse behavior, combines inherited predispositions with learning. This is why even a well-fed pet cat may still chase a mouse. Hunger affects hunting motivation, but predatory behavior is not controlled by hunger alone. The movement itself can be rewarding enough to start pursuit. To the cat, a mouse is not a villain. It is a small, fast animal matching the pattern the predatory system is built to notice. To the mouse, the cat is not a villain either. It is a moving collection of danger cues that survival systems are built to avoid. The famous rivalry is therefore emotionally misleading. Cartoons show revenge. Evolution shows incentives. The cat gains food or hunting stimulation by pursuing. The mouse gains life by escaping. Those incentives are strong enough to recreate the chase in every generation. Predator-prey evolution is often described as an arms race, but neither side needs to become perfect. The cat only needs enough successful hunts to survive and reproduce. The mouse only needs enough successful escapes to do the same. That means both species can keep improving while neither wins forever. If mice become better at hiding, cats benefit from better detection. If cats become better at ambush, mice benefit from earlier warning. If mice use tighter spaces, cats benefit from patience at exits. If cats hunt quietly, mice benefit from stronger use of scent and vibration. Every adaptation changes the value of another adaptation. But the battlefield is not fixed. Humans keep rebuilding it. Mud walls become stone walls. Stone walls become wooden houses. Wooden houses become apartment blocks. Grain pits become cupboards. Barns become warehouses. Ships carry mice to new ports. People carry cats to many of the same places. The architecture changes while the basic incentives remain. A mouse still wants food, cover, and a safe nesting site. A cat still notices small, moving prey. So evolution meets human engineering again and again. That is why the rivalry can survive dramatic changes in civilization. The animals are not reenacting one ancient battle. They are solving the same type of problem in new surroundings. Predator finds prey. Prey detects predator. Both adjust. Then the next generation begins with inherited tools and fresh experience. Now bring the story into a modern kitchen. The cat sleeps on a soft chair and receives food every day. The mouse lives behind a wall where crumbs and shelter are available. Neither animal needs the ancient village, but their nervous systems still carry older priorities. At 2 a.m., the mouse crosses the floor. The cat's head rises. Its ears point forward, its body becomes still. The house pet suddenly behaves like a small wild predator. The mouse detects danger and changes direction. For a moment, modern architecture disappears from the story. The same ancient logic is running under electric lights. This does not mean every cat will hunt every mouse. Individual cats differ in age, health, temperament, experience, and hunting motivation. Mice also differ in boldness, familiarity with the environment, and current risk. Some cats ignore rodents, some become intensely focused. Some mice freeze, others sprint immediately. Evolution creates tendencies, not identical robots. That distinction matters because nature is probabilistic. An inherited bias can make one response more likely without guaranteeing it. Learning then adjusts the behaviour further. A mouse that survives one attack can learn details about that location. A cat that nearly catches prey can learn where escape routes are, so each encounter adds personal experience on top of ancient biology. The modern chase is therefore both old and new. Old in its basic circuitry. New in the exact decisions made tonight. So why do cats and mice seem to fight in every generation? Because the rivalry is not being passed down as a story. It is being rebuilt from the same survival pressures. Cats inherit bodies and brains shaped for predation. Mice inherit bodies and brains shaped partly by the need to avoid predators. Both then learn from the world they are born into. The first literal cat and mouse encounter is lost to deep time. We should not pretend archaeology can show us that exact moment. What evidence can show is a later turning point that changed the relationship dramatically. Human settlements drew house mice into concentrated food-rich environments. Those rodents helped draw wildcats toward human settlements. That ecological triangle contributed to the domestication history of cats. So the most famous rivalry in the animal world may also be part of the story of civilization. Without stored food, mice would not have crowded some early settlements in the same way. Without those rodents, wildcats may have had less reason to hunt beside people. Without tolerant wildcats, the path toward the household cat could have looked very different. The mouse was never trying to create the cat. The cat was never trying to become our pet. Humans were never trying to build an evolutionary arena. Yet all three outcomes became connected. That is what makes this story bigger than a chase. It shows how species can reshape one another without planning anything. A grain basket changes mouse behavior. Mouse behavior changes where cats hunt. Cat behavior changes what humans tolerate. And thousands of years later, we call the result normal. The next time a cat freezes at the sound of scratching, remember what you are watching. Not an inherited grudge, not a cartoon war. An ancient survival system starting the game again.